Have you ever looked up at the sky and wondered, how does something as massive as a passenger jet stay in the air? A flying metal tube, weighing hundreds of tons, gliding smoothly above the clouds? It might seem like magic, but it's actually one of the greatest achievements of physics and engineering. And today on Knowledge Hub, we're unpacking the science behind flight, how planes really fly. At its core, the job of an airplane is simple: defy gravity by generating lift. But to do that, it has to perfectly balance four fundamental forces: lift, weight, thrust, and drag. Let's start with lift. Airplane wings are shaped with a special design called an airfoil, curved on the top and flatter on the bottom. As the plane moves forward, air flows faster over the curved upper surface and slower beneath. This creates lower pressure on top and higher pressure underneath, generating lift that pushes the wings and the plane upward. This principle is often linked to Bernoulli's principle, but Newton's third law plays a part too. The wings push air down and the air pushes them back up. But the wings can generate lift unless the plane is moving, and that S where thrust comes in. Jet engines pull in air, compress it, mix it with fuel, and ignite it. The resulting explosion blasts exhaust gases out the back at high speed. In reaction, the plane is pushed forward. The faster it moves, the more air flows over the wings, and the more lift is generated. At the same time, the plane has to overcome drag, the resistance of air trying to slow it down. That's why aircraft are built to be as aerodynamic as possible, with smooth, streamlined shapes that cut through the air efficiently. Then comes control. Pilots use a network of surfaces to steer and stabilize the plane mid-flight. Ailerons on the wings control roll. Elevators at the tail manage pitch, nose up or down. And the rudder controls yaw, swinging the nose left or right. Together, these controls allow for precise movement in three-dimensional space, from takeoff to landing. And it's not just about brute force and control surfaces. Modern aircraft are packed with onboard computers that manage everything from fuel flow to stability. Fly-by-wire systems translate pilot input into digital signals, helping planes stay efficient, safe, and smooth at every altitude. So the next time you watch a plane soar overhead, remember, what looks like effortless motion is actually a masterclass in fluid dynamics, combustion, control systems, and engineering precision. If you found this breakdown helpful and want to learn how the world around you really works, hit like, subscribe to Knowledge Hub, and ring the bell for more deep dives. Until next time, stay curious.